We got a squared plus b squared equals c squared. I would just make a quick note. Only can be used in right triangles. No other triangles except for right triangles. Okay, only used in a right triangle. You can't use it in any triangle you feel like. It's got to have a right angle in it. Most of us pretty familiar with that, I believe. So let's use it a couple times here just to make sure we're good with it. Go ahead and make a diagram right now for part A. In right triangle ABC, I'm telling you C is the right angle, and then label the parts 2 and 3. So go ahead and make yourself a right triangle right now. Angle C is the right angle. Put your right angle symbol in there, please. Make it, that's C. Right angle symbol here, Frank, that's C. Those are angles. Those are angles, everybody. Angles. That's your right angle?
No.
It says C though, Jeremy, not A. A and B can go anywhere just as long as C is your right angle. A and B can go anywhere. It's not going to affect your problem. And then we should have on AC, we should have 2. And on BC, we should have 3. And we're solving for AB. Okay, so here we go. Pythagorean Theorem. If you know two sides and trying to find the third, A squared plus B squared equals C squared. I'll do this one for you before I start calling on people. A and B are the two legs. That's where the right angle's formed. All right, the two legs, which we both know are 2 and 3. So that's going to be A and B. 2 squared plus 3 squared. The part across from the right angle is called the hypotenuse. And that's your C value. That's the value we're trying to find here, which is x squared. So A and B are your two legs. C is your hypotenuse. So now I have 4 and 9 equals x squared. Add 4 and 9, we get 13. And then my final step, I got to solve for x. Anybody want to take that part? Let's take the square root of both sides. Yep, don't hit your calculator up, please, because look at my directions. My directions say simplest radical form. Okay, simplest radical form. And I'm not going to go get into it because it doesn't happen here, but you can't break down 13 anymore. So this is in simplest radical form. There may be problems where we can, but that one we can't. So I'm going to leave it in radical form. So that side's the square root of 13. Any issues on that basic one? All right, B, go ahead, make yourself a rectangle, 12 by 15 rectangle. And then it looks like we have a walkway on the diagonal, so we're going to put a diagonal in. And I'm looking for how long is that diagonal? How long is that walkway? Let's put our 12 and 15 on the rectangle, please. 12 and 15, diagonal, however way you want it. Okay, what's going in for A, B, and C now? Now I'm going to start calling here. A, B, and C. Here we go, Frank. What's A, B, and C?
A is 12.
Okay, there we go. 12 and 15 can be switched if you want, but that's fine right there. 12 squared plus 15 squared equals x squared. 144 plus 225 equals x squared. And I get 369 here for x squared. All right, what do we do in the solve for x? What do we have to do on both sides here? Sarah, what do we have to do on both sides? 20? Square root both sides, good. Now take a look back at the directions. It says please round to the nearest tenth of a foot. So how long is the walkway then? Nearest tenth of a foot. 8, Connor.
I said it when I did it. I just came up with some decimal I didn't like, but it was 19.2.
Yep, 19.2. Round to the nearest 10. Done. Nope. Other questions here? Okay, look, honestly, those are 10th grade questions. Okay, those are 10th grade questions right here. This next one is where we are at right now in this level of math. All right, something like this. Okay, something like this. So I got a squared. It's a right triangle. I know something about all three sides, so I'm going to get Pythagorean Theorem out. All right, what should I be plugging? What's the A, the B, and the C value here, according to this triangle? 6. Ryan, what's my A, B, and C here?
Your A could be 8 squared.
Okay, hold on. Yep, everyone's good. 8 squared, there's one leg, and what would be my B then?
X minus 4.
X minus 4. Watch how I write this. In parentheses, X minus 4 squared, and then what's my hypotenuse or my C?
X.
Just X squared. Good. Everyone see? We're all right? A, B, and C, where they get put in. All right, now we got to do a little algebra, don't we? 64 for 8 squared. This will stay x squared over here. All right, now what am I looking for when I say x minus 4 squared? I'm not looking for you to distribute the exponent of 2. I'm looking for you guys to go off to the side of your paper right now and do x minus 4 times itself, x minus 4. So you're going to have to double distribute, FOIL, whatever you called it back in the day. That's what it's looking for when you square a parenthesis like that. Multiply it by itself again. Okay, what did you get when you double distribute or FOIL? Not looking for any final answers. I just want to know x minus 4 times x minus 4. Ryan, 6, go ahead again.
X squared minus 4x minus 4x plus 16.
Perfect. Good job. All right, there it is. When you double distribute, if you need help with that, got to get in here. All right, we got to clean up some stuff, don't we? Because there's a lot of things we can combine on the left side. So x squared, there's nothing I can combine with that. Clean up the x's, though, for me. Clean up the x's. 1, Elizabeth, what can I combine? Yep, minus 8x. And then how about my numbers? There's a couple numbers up there I can combine. 12, Zach. What can I combine up there?
64 and 16.
64 and 16 give me 80. Good work. Equals x squared on this side. Good. All right, so usually when I see an x squared, I got to set one side equal to 0, so maybe I can factor. But what's going to happen when I bring over the x squared here? If I have x squareds on both sides, what's going to happen here? Well, what happens with my x squareds? Everyone see they cancel. Yep, Clara. Sure. Yep, just let me give you a pass. Go ahead, cancel those out. See if you can solve it with the 0 equal now. Negative 8x plus 80 equals 0. Need someone to go up and down here, okay? Do you know anybody comfortable with you? Warren, you want to walk her down?
Yeah, sure.
Thank you. Okay, so you had negative 8x plus 80 equals 0. You brought the 80 over. Negative 8x equals negative 80. So your final answer here for x, positive 10.
Could we
Okay.
have brought over the negative 8?
What's that? Cool, we could have brought over negative 8x and done it that way. Yep, should have got positive 10 either way. Okay, shouldn't have got negative 10 out of here. Positive 10 either way. Any issues there? Going? Okay, so there's Pythagorean Theorem. Quick review on Pythag. You probably don't remember this part of geometry so well, which is your special right triangles. All right. First one I'm going to introduce is called the 45, 45, 90. It's a right triangle, but it's got special. That's what I mean by special right triangle. It's still a right triangle, but it's got special degree measures in there. In this case, both of them are 45 and 45. All right, because both of them are 45, that means the sides across from the 45s are both the same. Okay, whatever's across from this 45 is the same value across from this 45. So I'm going to start by putting x's here because it could be any value, but they're both the same. So if one's 6, the other's 6. Okay, now what about the hypotenuse in a 45, 45? That's this side, so we take the side across from 45 and we multiply it by the square root of 2. Okay, so the sides across from the 45s are always the same. And if you want to find the hypotenuse, you take that side and multiply it by the square root of 2. So can you go down the letter B for me so we can apply this right now? Go down to the letter B for me. Can we draw this first? The ladder leaning against the wall at a 45-degree angle. All right, so it's just draw your right triangle. Where's the ladder on here? Hypotenuse, correct. There's your ladder, the hypotenuse. And it leans against the wall at a 45-degree angle. So does everybody see this is going to be a 45, 45, 90 triangle we talked about? Ladder's 12 feet long. What should I label 12 feet then? One of the legs or the hypotenuse if the ladder is 12 feet long? 1, 8. Oriana, what should I label 12? The hypotenuse or one of the legs? The ladder. What did we say the ladder was? Ladder leaning against the wall. What's the only thing leaning against anything here? Hypotenuse has to be 12. There's my ladder. How far up the wall does the ladder reach? So which side are we solving for? Left side or bottom? Left side or bottom? How far up the wall does the ladder reach? Left side or bottom? What are we solving for here? 3, Olivia? How far up the wall does the ladder reach? This left side or this bottom side? Where's the wall? Left side. So I'm going to put an X right there. All right, how can I solve for X using my rules? Ready? Go back up to the triangle you just had up there. What is in place of the hypotenuse? What did I write on the hypotenuse on a 45, 45, 90? What did I write on the hypotenuse? 12, Zach, what did I write on there? I wrote the hypotenuse is x square root of 2. Everyone agrees? And now you know what is it that equal to in this problem? 12. Okay? So x square root of 2, which I know is the hypotenuse on a 45, 45, is equal to 12. Now we have to solve for x. So how do I get that x by itself? Is the question. Okay, it's x times radical 2. So how do I, using your knowledge here of getting rid of things, how do I get rid of the radical 2? 9. Frank, how can I get rid of the radical 2? I need x by itself. What's happening between the x and the radical 2? How do I get rid of the radical 2 then? Okay, so let's go, everybody. Let's divide both sides by radical 2. And here's where our math, 12th grade math comes in. All right, because your calculator's not going to help you here. Your calculator's going to give you a decimal, which it should. Everyone see in parentheses what I have here. Final answer in simplest radical form. You cannot, and you guys probably learned this last year. Maybe you didn't. You should have. You can't have a radical in the denominator. That's always a no or no. Can't have a radical in the denominator. So I'll let anybody take over here before I show you. Anybody remember how to get it out? Nope. Close. You multiply the top and the bottom by the radical. So I'm going to multiply the bottom by radical 2, top by radical 2. Okay, you cannot have a radical in the denominator. To get rid of it, you multiply the top and the bottom of the fraction by the radical. Here's why. On top, I can't do much. One's a whole number, one's a radical. I can't do much. 12 times radical 2. On the bottom, here's why you do it. Anybody remember a radical times itself? That's fine. You'll remember. Do it in your calculator. Radical 2 times radical 2. You shouldn't get a decimal. What are you getting in your calculators? Radical 2 times itself. Number 2, right? Yep. So radical 2 times radical 2 is just 2. No more radical, right? But there is one more step. That's not simplified all the way. And no, I can't cancel the, good idea. I can't cancel the 2's because one's underneath the radical and one's not. I can't, what do you mean simplify?
So like 6 over 1.
12 divided by 2. You can do 12 divided by 2, which is 6 radical 2. There's your final answer. So I set the hypotenuse equal to x radical 2 because that was my rule up here. Set it equal to 6, all right, 12, x radical 2 equal to 12. Divide and then get that darn radical out of the denominator. That's really what I'm going to be asking you to do, and that's it. And the last one we'll probably have time for here is our other special triangle. You got 45, 45, 90. Make yourself another right triangle up here. And now you may see the degree measures 30 and 60. That's a special one. Okay, across from the 30, you're just going to see a number across from the 30. I'm just going to leave it as x. If you want to find the hypotenuse now, ready? If you want to find the hypotenuse, you take whatever sides across from the 30 and double it. Double it. So if this is 6, that'll be 12. 5, 10. 4, 8. Okay, you just double the side across from 30. So I'm going to put 2 times that side. So the hypotenuse is always the side across from 30 doubled. And now here comes the tricky part, is the side across from 60. It's this side across from the 30 times radical 3. Okay, the side across from the 30 times radical 3.
Why the radical 3?
Fits in the Pythagorean Theorem. If you did a squared plus b squared equals c squared, they're equal. Yep. Okay, so before we get out of here, let's try out letter A. Please draw yourself the correct diagram first as I walk around. That's what I want to see first. Right triangle ABC with right angle C. Angle A is 30. If A is 30, what's B then? 60. Okay, here we go. Ready? BC is 8. Look where 8 is. I need somebody to tell me what 8 is across from what angle. 8 is across from what angle? 2, 1, 6. Ryan, 8's across from what angle measure?
30.
The 30, right, everyone? The 30. It's across from the 30. There's my x value. What am I looking for? AB. Where's AB across from? AB is across from 20. Sarah? What's that? AB. What angle is AB across from? The one I'm looking for. Angle C, which is my right angle. So if I look at my rules, what do I do with the side across from the 30, 8, to find the side across from the 90? What do I need to do to that side? What's the rule? I have this side as 8. What do I need to do to it to get to the side across from 90? What's it say? 5, 3. Olivia, what do I need to do with it? I got this side, but I need to go here. This is x, and then that's 2x. So what should I be doing with the 8? Multiply it by 2. So AB, everyone, 8 times 2, 16. And that's all it asked me for, though. And we're probably not going to have enough time to get to the next one.
Do we use the midpoint formula in the last one?
No? Nope. But hey, delta math's there. Okay, I don't have time to do it tomorrow in class. Delta math is there if you want to try out Pythag and these special triangles.
CD and AB equal? Are they equal?
CD and no. CD and BC are because they're both across from 45s.